In this video, we're going to be looking at this problem from the AMC 8 2022. This is problem number 15. The problem statement says, Laszlo went online to shop for black pepper and found 30 different pepper options varying in weight and price, shown in the scatter plot below. In ounces, what is the weight of the pepper that offers the lowest price per ounce? So we've got the plot here, and we have the price in dollars on the left, the y-axis, and the weight in ounces down here on the bottom for the x-axis. So we have some plots here. They want the lowest price per ounce. That means we're going to have a fraction where the numerator, we can write this price per ounce as a fraction, where the numerator is going to be the price, and the denominator is going to be the weight in ounces. And we're trying to find the lowest price per ounce, which means this fraction right here needs to be as small as possible. We want it to be, what it needs to be small as possible because they want to know the lowest price per ounce. So that's the goal of this problem. We want to try to find values for the price in dollars and the weight so that we have the smallest possible price per ounce. So we have a variety of points here. We can begin looking at them to see what the relationship is. Let's take this point right here. This one has a price of just over 1. So we're going to have a fraction, we don't have to have actual values here, we can just estimate. Our fraction might look something like 1.2, and then our weight is 1. It's right on the 1 line over there, so 1.2 or 1. This is slightly larger than 1, and while this may seem like a pretty small price per ounce, it's not as small as we can go. Take this point, for example. This is going to be 2 over 2, because the weight and the price are both equal to 2, which is 1, even smaller than the one we had before. So we could keep looking at different points, and we discover that 1 is in fact not the smallest we could go. All you have to do here is look at some of the other points. For example, this point up here has a price of around 4.5 and a weight of 5. That's going to be less than 1. And you might stop right there. You might think that, oh, that must be the smallest right there. That's a very small fraction, and just answer E5 right away. But in fact, that's not the answer, because that's not as small as you can go. We're looking for the smallest fraction, and for example, if you have a fraction 4 out of 5, that's going to be larger than a fraction 2 over 3, just how it works. It's because the numerator is going to be smaller for the 2 over 3 fraction, and that results in the entire fraction being smaller. And sure enough, 4 over 5 is like in the range of, it's 20% higher than, for example, 2 out of 3, which is 66%. So obviously, that's not going to be the same. So in fact, this 4.5 over 5 is not the lowest we can go, because we've also got this point right here. This right here is going to be 2.5, that's the price, and the weight is going to be 3. So it's 2.5 over 3. That is the price per ounce fraction there, and that's going to be smaller than 4.5 over 5, because we know 4 over 5 is larger than 2 over 3. So same kind of thing there. And we can confirm that's as small as we can go by looking at some of the other points here. We can look in the 2 range here. We say, oh, or there's that 2, comma 2 again. And we have 3, comma 2, which is obviously way too big. There's nothing in the weight 2 ounce range that has a price lower than $2. Same for the weight 1 range. There's nothing in this range here. And this weight 3 over here is the only weight that has a point with a price also less than 3. And also, the overall fraction is smaller because the weight and the price values are both smaller than we had with the 5s over here. That means the weight of the pepper that offers the lowest price per ounce must be 3. Answer choice C here. So that's how we would solve that problem. There's not really any algebra or serious math there. It's really just logic and knowing that when you have a fraction, if you have a numerator and denominator that are smaller than another fraction with a larger numerator and a larger denominator, then that fraction, the first one's going to be smaller, like we had with the 2.5 here, and the 4.5 over 5. So that's how fractions work. That's the how you can compare them. So that's how you would solve a problem like that using logic and the relationship between fractions and their numerators and denominators. That was problem 15 from the 2022 AMC 8.